Hello, everyone, and welcome back to class. I'm really excited this week to welcome you to our next topic in the course, and that's because we are going to take another look at the ongoing concept of our dynamic planet. You see, our planet is very dynamic. In the previous weeks, we have taken a look and found out that the rock and mineral forming processes have to start somewhere, and that our continents drift around the planet based upon evidence using plate tectonics. And this tells us that deep below our Earth's crust, there are processes that are undergoing, but we just don't have the technology to be able to completely investigate them. Some scientists actually believe that by the time we have ventured out into space and have developed our own civilizations, then we can actually better understand what is exactly is going on within our Earth's crust and core, and also our deeper oceans. But that's going to be a topic for a different time. This time, I want to be able to combine a concept of the dynamic Earth with more physical lines of evidence that can be exposed all around us. And we do that by understanding natural disasters. You see, as humans, we have to build and live in places where these natural disasters can occur. And we've seen these in modern times. By the time this recording has gone on, there's been earthquakes in the Middle East, volcanic eruptions in Southeast Asia. Along the Andes, volcanoes are constantly erupting, ejecting out newly formed igneous rocks. And so we need to be able to use that as a vehicle of communication, that natural disasters are an ongoing process, a side effect of living on planet Earth. We are going to investigate that model further. In the lecture, we're going to have some discussions on what Earth scientists do and how we interpret earthquakes and the data that they produce. And an earthquake really simply is just the crust being able to move around and releasing seismic waves. And then we're also going to take a look at volcanoes. How do we describe them? In lab, we're going to have some simulators and activities that will allow you to work with that data and be able to manipulate it and make your own observations and your own scientific inferences, which will generate a hypothesis and allow you to establish and tie in or link together a concept of the physical and the conceptual. But let's actually venture into time. I want to welcome you to the year 79 AD. The date is August 24th, and the day started like any other day. It is now 8 o'clock in the morning. Here we sit on a second floor veranda. We are looking to the northwest. It is the start of Emperor Titus Caesar Vespasianus' reign, and that mountain to the northwest is the famous Mount Vesuvius. Yes, that is right. We are now sitting in the famous city of Pompeii. As you can see, there's a little bit of shaking. This shaking is the start of disaster. smoke plumes are starting to emit from Mount Vesuvius, a way for forecasting that something unusual is going on beneath the Earth's crust. And then there it is, the eruption, the start of the end. It is now 3 o'clock in the afternoon. The eruption is ongoing as the volcano erupts, rapidly cooling rises to the surface of its eruption, and it continues to fuel the fire. It is now 8 o'clock in the evening, and the city has been leveled through a massive, extrusive eruption event of Mount Vesuvius, a cataclysmic event for the region. It was once said that Emperor Titus actually saw this eruption occur all the way in Rome. It is now 6 a.m. and the eruption is still occurring. If you look at this wall of dust that is slowly approaching, is one of the last throes of the chaotic eruption that Mount Vesuvius has produced. These flows are called pyroclastic flows. They produce tephra, which is a mixture of still hot rock, sediment, and gases. This rapidly covers the city of Pompeii for archaeologists to discover years later. Pompeii and her sister cities are essentially wiped off the map because of this natural disaster.